This should be, remember that if any, it doesn't have to be something exotic like this. If someone tells you, hey, I've got this thing, it's a solution to this polynomial, that is, it's a zero of the polynomial, well then, you know, after our discussion recently too, that x minus that thing is a factor, isn't it? So that's all that's saying there. For 3 plus 2i is a zero, the function. That's exactly what we mean by this, right? So that's certainly the case. If this is a polynomial with real coefficients, which it is, then you know that these solutions come in conjugate pairs. Do you remember that? So 3 plus 2i is a solution, 3 minus 2i is a solution. Check that box too. Well, we've just said, like within the last 2 seconds, that 3 minus 2i is the other solution. So this is definitely false, the fourth one, right? And then the last one, the equation is equivalent. I think we've established that each of these is a solution, so each of those things, x minus the one, x minus the other, is a factor. So I think we're done. That should be familiar. We've done some factoring like that in our life, haven't we? Where they're terrible like that. You just do x minus the one, x minus the other. So those were the boxes you should have checked on that one. Yeah. I'm going to post the video solutions still. Yeah. In my first class, I recorded the solutions to all the problems you've seen, but I didn't do these yet. We didn't get to these in my previous class. So we'll have, together we'll have. So we're better than them. No. It took me a while to write those out in that class. So now we'll have a complete set of explanations on all the problems. So I spent a little more time on those earlier problems. If you want to go back and see, you'll have some video solutions of me working it out, including right now. Does anyone want to give a shout out to their mom or anything? This will be on YouTube later. So. Rock and roll. All right. I don't have much to say about these. I'll work these with you here. So really, it's just as if the parentheses aren't here, right? So you just get 9 minus 4i. Here we need to be just a tad careful, but not that careful. We just need to make sure we treat this negative as it applies to everything in the second set of parentheses. So I'll write one intermediate step, 4 plus 7i minus 2 plus 6i, right? And now we can safely resolve this. It's 2 plus 13i. Is that what you got? Yay. Multiplication. Don't multiply up on these, guys. I see people do that all the time. They're like, ooh, parentheses. I should like FOIL. Whoa. Slow down. Make sure you actually understand what you're doing at all times. So this is the time, though, to multiply this out. We get 3 times 4 is 12 plus 27i minus 8i minus 18i squared. And then nice things happen here. We get 12 minus 6i plus 18, because the I squared is a -1. We've got a minus a negative, so, okay. So I think in the end we get 30 minus 6i. Yeah? Where did I go wrong?
What about 3 times 9i?
Oh, 3 times 9i. I said 27 out loud, didn't I?
Yeah, but you didn't write it.
27.
I somehow missed the 27 in there. Okay.
So then that's
Good.
It's 23. Yeah.
What is that? 19 in there?
Yeah.
All right. So is that better now?
Yeah.
Good. Thank you for paying attention. Down here, ooh, we love difference of squares, don't we? 4 minus 3i, 4 plus 3i. That comes out nice. Well, we'll write it all out just for those who can't see this coming. But you get 16 plus 12i minus 12i minus 9i squared. So, and this always happens with the difference of squares. That's why some of us who are in the know got excited as soon as we saw this. We're like, that's going to happen. All right, and then so you get what? 16 plus 9, which is in the end 25. These are not just a difference of squares. Remember, those are complex conjugates, right? And in fact, when you multiply a number by its conjugate, you always get something real. In fact, on the last quiz or whatever, you prove that, right? In general, that a minus bi times a plus bi always gives you a squared plus b squared. Didn't you prove that on the last quiz? So there you go. That's that same thing happening. So I squared is -1, remember? Okay. 7 plus 5i, just do this carefully. Remember, that's 7 plus 5i. Oops. Times 7 plus 5i. You just got to do the heavy lifting here, okay? Here we go. 49 plus 2 copies of 35i plus 25i squared. So what do we have in the end? Let's do 2 steps here. 70i in the middle, and minus 25 on the end. So what is that? 24 plus 70i. Okay, great. Remember how to square binomials. Do these things carefully, right? You just saw me make a mistake. Number 10, we've got some quadratic that they're not telling us about. Who knows what it is, but we'll call it q of x equals 0. And the two solutions are x equals 3 and x equals 7. So what are the factors then? Yeah? And what points do we have on the graph for sure? 3, comma 0, and 7, comma 0 are the location of the x-intercepts, and 3 and 7 are the zeros. I don't know. There's so many different ways to say the same thing. But we want to make sure you understand that that's true, that these are all saying the same thing. Every single one of these implies directly every other thing here, right? Okay. Moving smartly along. Let's solve some quadratics. This is where it's at, right? So do these in the most efficient way possible. I'm going to choose a method that I think is most appropriate. I'll keep in mind you might have a different method, and I want to make sure that you kind of compare your method to my method. I think the most efficient way to do this one is just take square roots. So you get plus or minus root negative 25, which we know we can actually resolve. With real numbers we can't, but with imaginary numbers we can actually say that's plus or minus 5i. Okay. Over here, don't be expanding that out if you don't have to. That will lead to good solutions too eventually. But this is another one just ready for you to take the square root, right? So here we get plus or minus root negative 16, which is again a nice thing, isn't that? It's just 4i. So we get x equals negative 3 plus or minus 4i. Down here, this one looks like I'm already moving the 15 over in my mind. I'm trying to factor it. I don't see that happening very nicely. This one, it seems like, would be a very nice candidate for completing the square, right? Do you see it? Because the leading coefficient is 1. The coefficient on x, the b value, whatever you want to call it, is even. This is going to be beautiful, right? What completes the square? What completes the square? 9. Draw a picture if you need to, right? But 9. So we get x minus 3 squared. Just check us on this. Don't believe us. And then I think you can see that the solution then is 3 plus or minus I root 6, right? Yeah? Just inverse operations on that thing. Do you see how nice that is? Completing the square gets you a solution real quick. Some of you might have actually used the quadratic formula. I hope you see the relative merits of each method, right? Here is finally one, well, yeah, I think I'm going to use the quadratic formula. I'm just trying to factor it in my head, and it's just not working real well. So I'm using the quadratic formula right off. Here we go. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you know that formula. What does that come out to? 20 times 3 is 60. Four minus 60 is 56. Negative 56, so we'll have like an I root 56 over 10. You could actually simplify that a little bit. 56 is, nope, just kidding, you can't really, that's good. That's a great way to leave your answer. E, interestingly, I've left no room for, so. It's right, it's all good, I got this under control.
You can do it.
What's wrong? It's divisible by 4, and then you can knock out a 2 everywhere, right? You want to do that? I don't know that it makes it that much better, but it is true. You can like write this as, is it 14 over 5? You could write it that way too, if you can figure out why. Good for you. Okay. Shout out Samantha's mom. Okay. Where's my blank screen here? White screen. There we go. Read that problem off to me. E goes.
2x squared plus x plus 20 equals parentheses x plus 1 parentheses squared.
Yeah?
Yeah.
Did I write it right? Okay.
Yeah.
I don't see a good way in on this except expand this and just make this happen, right? But you're a grown-up kid. You can do this. Okay, here we go. Yay. Move everything over to one side. How about on the left side so we get an x squared minus x plus 19, yes? Equals 0. Don't see that factoring, do you? So feed that to the quadratic formula maybe? Or, I don't know. Oh, yeah, I think that's probably what I do because this is a 1 there. Whatever. Or do you want a complete square? It's up to you. They're both easy. Here. Okay.
That's factored.
All right. Well, it doesn't factor nicely. So negative b plus or minus the square root of b squared minus 4ac all over 2a, just 1. So we get 1 plus or minus the square root of 1. What's 4 times 20 is 80, so 76. Right? It's like 4 less than that. How are we doing? Check me out on these pieces of arithmetic here. So 1 plus or minus I root 75 all over 2.
Yeah.
And there's not really a nice way to knock anything out of there, really. So I think that's good. You could actually simplify root 75 a little bit, but what is that? 5 root 3? 75 is AKA 5 root 3 if you care. If you want to write that way, you can too. Yeah? Did you see that? Yeah. Questions on E in particular? Because I'm going to make that go away in a second. I'm doing these quickly as if there's no room for error. But there's plenty of room for error, as you've seen, right? It's easy to like miss a negative or whatever. I mean, don't be discouraged. I mean, I just did that in like 30 seconds, but I mean, if that took you 20 minutes last night, like you're forgiven. Okay, it's all right. These are tricky. This is not. I don't mean to trivialize this problem. There's a lot of places you could easily go wrong here. Okay. All right, moving along. Number 13. We failed to give you this formula, but I promise that if this is a problem that's given to you on the test or something, that this formula will be provided. And then the last question. Is this the last question?
Yeah.
Okay.
Oh wait. Yeah.
Good, and then we can come back and hit another question if we want, and hit it again if you want more detail. We've been running through these, so hopefully you found this to be a good use of time, though. I don't know. We can hit this shotgun approach here, right? Lots of problems coming at you. Choose the appropriate number from the number bank. Nice that they gave you a number bank. That we didn't have to do that. Let's just cover it up and see if we can fill it out in without even thinking about that.
Yeah.
Okay, log base 2 of 1/2. 2, that is, remember the question you're always asking with the log function is 2 to what power gives 1/2, right? So, do you remember your thoughts about exponents here? What exponent does that trick? This one, same kind of thing. E, this time. E to what power gives 1? 0. That would be true if we did anything to what power gives 1. The answer would always be 0. Over here, this is 10 to what power gives 3. Let's write that really clearly here. 10 to the third is equal to this number, right? Right, because 3 is like the answer kind of for this problem. So what we're saying is that 10 to the third is what gives this number. Well, what is that number then? 1,000. And then just run it through again the forward direction. Is if we're asking what power do we have to raise 10 to get 1,000? Isn't the answer 3? Does it just come at it from a couple different angles? Down here, the log base. What base are we talking about here? Now we want to rewrite this. We're thinking this to the first equals 10. So that makes it more clear, maybe in exponential form. Isn't that going to be a 10? Okay. And in general, log base b of b is always 1, regardless of what b is, whether it's 10 or another number. And then here, log base 2 of what gives 5? So we're looking for the number that is 2 to the 5th, right? So that's 32. And then just check it again. Isn't it true that the log base 2 of 32 is 5? What 2 to what power gives 32? Oh yeah, 5. If we run it that direction in our heads, it works too. E to the something gives 1. We already had this discussion, didn't we? E, right? Log base E of E is 1. Now, we can go back and check the boxes. Did we actually get all 6? Yay. Okay.
Wait, so ln is log to the e?
Log base E, yeah.
Oh, I thought that was log to the 10.
No, log, just log without a base is called the common log. That's the answer to what your buttons on your calculator do too, right? The one that says just log is the log base 10, the common log, and the log base E is the ln button on your calculator. Okay. Any other questions or thoughts at all about these that I can go back and hit again or say something else or yeah.
So our homework is just the studying stuff.